This video is going to review describing motion through speed. An important part of describing an object's motion is looking at that object from a reference point. In the picture you see a mail truck that is visiting mailboxes along the road. We can use the position and change in position of the mail truck to try to describe its motion. An important thing to note when looking at an object's motion is something called its distance or its displacement. Both of these terms may seem very familiar or similar. However, there is some difference. The distance is the length of distance between the point of measurement and the object, whereas displacement is the total change in length from a certain position. In the picture, the person running on the field starts at the bottom and moves up 50 meters and then back towards the starting line by 30. Now the displacement, because we're measuring from the starting line out, is only 20 meters. However, the total distance that has been run by the runner is 50 out and 30 in, which is 80 meters. So when we are looking at problems involving objects in motion, to find its speed we must use distance rather than displacement. When describing an object's speed, we often use a measurement called speed itself. In the United States, we use miles per hour to describe an object's speed. However, in science, we use the units kilometers per hour and meters per second. Now, we get units to describe an object's speed through the equation speed equals distance divided by time, or S is equal to d over t. In the bottom right-hand corner here, we see a speedometer, which is a device used to determine the speed of a vehicle. Note that this speedometer might be from a vehicle in Canada because it's showing kilometers per hour, which is the units that are used in Canada on their road system because it's metric. The inner orange labels show miles per hour. So 55 miles per hour in the United States is similar to 90 kilometers per hour in Canada. So let's look at the mail truck example. Let's say the mail truck moved a distance of 50 meters in 25 seconds. We want to know what is its speed. The first thing you want to do is identify the equation that you're going to use. We know that speed, or S, is equal to the distance divided by the time. The distance is going to be written in the numerator, 50 meters. And the time it took to move those 50 meters, time in 25 seconds, is in the denominator. In the calculator, you would type in 50 divided by 25, while 50 divided by 25 is 2. And our units would be m in the numerator and s in the denominator for meters per second. And that would be the answer that you would come up with. Something to think about is that speed is rarely constant. So we usually calculate average speed. And average speed is our distance divided by time. If you think of the mail truck, it has to increase its speed from a stop and then slow back down as it approaches its endpoint. You can also think about this as a long distance trip. If you are driving from Pittsburgh to Erie, the distance you travel divided by the time isn't your speed the entire trip, but only the average speed that you were traveling. At points in your trip, you may be moving faster than average speed, while other points you are traveling much slower. Comparing average speed to instantaneous speed is what we saw with our speedometer. The instrument on a car tells you how fast you're moving. That instrument tells you, without worrying about the distance being traveled over time, can tell you how fast instantaneously that object is moving. Airplanes also have a similar device to tell airspeed. In the graphic here, we can see how changing speed over distance can be achieved during a particular trip. As the car is moving, it gains speed and then changes with conditions of the road. Now, if you took the distance traveled by the time it took to do that, you'd have your average speed.